Now we'll be dealing with a kind of addition polymerization, and that too in dienes. So dienes we know are two times double bond placed in a compound is called diene, and we'll be dealing with conjugated dienes. Now, to show an example of conjugated diene, we can write CH2 double bond CH. Now, conjugated dienes, so they should be in alternate, the double bond should be alternate to each other. And we take n units of this monomer that we'll be dealing with. The first kind of addition that we'll be performing is the 1,2 addition. So in the 1,2 addition, we will take our monomer and convert it into the species that we had been previously dealing with. So CH2 double bond CH, and then this particular chain over here we'll be attaching as a group, and we've been dealing with this since the beginning of polymerization. So CH double bond CH2. So the same compound is written in this manner. Now when 1,2 addition is performed, we'll get a certain product, and we know polymerization occurs of this monomer that we are dealing with, and the chain, the double bond opens, and we have got CH2 with CH open on both sides and connected to our group, which is CH double bond CH2. And these will be n in number, so it will form a long chain. Now, this particular compound that we have obtained after polymerization, this polymer that we have obtained, this polymer will not show any geometric isomerism. So, not show, it doesn't show any geometric isomerism, which is represented as Gi. Why? Because the double bond is not in the midsection. So we'll be performing another addition. So now this was 1,2 addition. We'll be dealing next with 1,4 addition. So 1,4 addition. Now what is 1,4 addition? So we take the same monomer that we had, that was NCH2 double bond C H single bond CH double bond CH2. So this was our monomer initially. Now we'll be performing 1,4 addition, and when 1,4 addition takes place, we get this kind of polymer. So we get CH2 CH. Now what happens is that the double bond between 1, 2, 3 and 4, let us name them, and the double bond between 1 and 2 breaks and gets attached between 2 and 3. So we have a double bond over here. Similarly, the double bond between 3 and 4 breaks, and we have only got a single bond here accompanied by our CH2, followed by another unit, the same unit again. So CH2 CH, the double bond appears in between the third and the second, and now we have CH again and CH2. So this will be n units of this. Now the repeating unit is this one. This particular unit is the repeating unit. That is, this is the repeating unit. So this is how 1,4 addition is taking place, by removing the bonds between 3, 4 and 1 to the double bonds, and they shift between 2 and 3. So this was 1,4 addition. Now why are we starting this? Because our next example that we are dealing with is 1,4 polymerization. So the next example that we'll be seeing is natural rubber. So in natural rubber, so the monomer for natural rubber is, we have to remember this in the long run, isoprene. Isoprene is our monomer. Now this isoprene, let us draw it. It is CH2 double bond C CH3 followed by CH double bond and a CH2. Now we have taken n units of this monomer, that is isoprene, and now after polymerization, what we'll obtain is a polymer which is natural rubber, of course, and it will be something like this. So CH2, a single bond, C, CH3. Now the double bond we know shifts in between these two, and we have got CH, a CH2, and this will continue, and we have n units of this being repeated again and again. Now notice here that when we discuss 1,2 addition and 1,4 addition, this addition was under the category of 1,4 addition. So this is 1,4 addition which is happening, and we can call it 1,4 polymerization. Okay. So the product that is being developed, this polymer which is developed, is called poly, and since poly means many, it is many isoprene, polyisoprene, also known as natural rubber. Now, this natural rubber, we notice that the double bond over here lies in between. When we look at our 1,2 addition, there the double bond was not lying in between. We said that there will be no geometric isomerism. But in this case, the double bond lies in between, and we can clearly see and say that this will show geometric isomerism. Geometric isomerism is shown in this particular polymer because the double bond is in between. Now, what is geometric isomerism? That is, the compound will show two forms, that is cis and trans. So if we look at this particular polyisoprene, this polyisoprene is actually the cis form of polyisoprene, is called natural rubber. So if we look at this, the cis form will be C double bond C, and in cis we know that the groups will look something of this sort. So CH followed by CH2 open at one end, followed again by CH2 open at the other end. Now this, when we repeat it n number of times, this is actually the cis form of polyisoprene, and we can say that the cis form of polyisoprene is natural rubber. So since it is showing geometrical isomerism, it becomes important that we mention whether it is a cis form or the trans form, and we say that the cis form is actually the one which is behaving as natural rubber. So we have to remember here that the cis form is behaving as the natural rubber. Now the question arises that we have to draw the transform also. The transform will look like this. So the transform of this polyisoprene will be something like this. So we'll have CH3 group over here, and since we had an H over here, it shifts. So H shifts over here, and then we have again got a CH2 group over here. So this being repeated n number of times, this is the transform, and this transform of polyisoprene is called gutta percha. So this is known as transform of polyisoprene, and this is called gutta percha. Okay, so these are the two forms. Now let us see synthetic rubber. What is synthetic rubber? We just dealt with natural rubber. So if we are dealing with synthetic rubber, now synthetic we learned was man-made. So synthetic rubber. Now synthetic rubber is made up of chloroprene. So the monomer over here is not isoprene but an addition to it known as chloroprene. So we will have the chloro group over here. So if we draw the monomer, it will look something like CH2, the double bond C attached with the chloro group Cl, CH double bond CH2. We take n units of this because the monomer is taken chloroprene is the monomer over here. And when we perform polymerization, so we're performing polymerization, what happens is we get a polymer and this polymer will look something like this. So CH2CCl double bond CH2. Now we notice the double bond has shifted and this particular addition is known as the 1,4 addition. Again, this is the 1,4 addition that we are seeing again. Okay. And the particular polymer that we have just obtained is called polychloropene. Polychloropene. Notice how we just add poly to the monomer name and we write the polymer's name. Now our polymer over here called polychloropene is also known as diprene. And this is what is synthetic rubber. So this is synthetic rubber. Okay. So this was synthetic and natural rubber that we just saw. And natural rubber was nothing but the cis form of polyisoprene, and we know that 1,4 addition, due to 1,4 addition, geometric isomerism is shown. So we have to keep these few points in our mind.